Here is another example of an application of a for loop to traverse a vector. Remember that traversing a vector is going through each element of that vector to do some kind of analysis. Some of the examples brought up before were finding multiple maximums, or calculating derivative and quantities at specific data points like velocity and acceleration, or calculating the area under a curve, but not a curve that's a continuous function, and that was a previous tutorial. In this one, we assume that we have a bunch of xy data points for a curve, and we're asked to count how many peaks there are, so how many bumps there are in the curves. Now, there is actually no function for this. There is the max, but it only gives us the very, very highest peak. But if there's other little peaks in between, we won't be able to find them. And again, there's absolutely no function that can do this. So the only solution that we have is to go through every single data point and figure out if there is a peak. Now when you think about these problems, always try to find some kind of logic. Maybe it's math, maybe it's equation, but maybe it's just looking at visually what does it mean to be a peak. Here you have 3 examples, and none of them are peaks. A peak would mean that there is a point that's higher than the other 2. So right there, that's the logic you want to apply. You could try to calculate a slope, but there is no actually slope equals 0 anywhere, since the 2 data points on each side are completely lower. So it's all that we can look at. Now to be specific, now you start moving to math. Now that you have the logic, what does it mean for a point to be higher than others? The only data, remember, that we have is the x and y coordinate. Well, that's exactly what the y is. So if the y coordinate is higher than both the y coordinate of before and after, that means we have a peak. So generalize. Now that you know your logic, you know the variables you're going to use, you knew what value you're looking at, the y coordinate, try to think of how you're going to put that in the machine. The vector of y coordinate is known. You have values in there. You don't know its length, but length is a function that can actually calculate that, so that's okay. But now we have to translate this. The y coordinate is greater than the one before and the one after. So if you're looking at a k position, the index equals k. What is the index before? What is the index after? Once you put that together, then it's simply logic. If the y position of k minus 1 is less than the y at position k, and the y at position k is greater than the y at position k plus 1, that means we have a peak. So notice how gradually I went from logic, trying to figuring out an idea, to actually bring it to mathematics, some kind of math, and then bring it to programming. Always try to follow that idea. Then your goal is finally to put the for loop together. But sometimes the logic doesn't allow you to look at every data point. You cannot traverse every single data point. In our case, when can you not apply this? In other words, when will this crash? What k value can't happen? Imagine you're looking at k equals 1. Well, that's the very first element of your vector. So when MATLAB's going to try to do k minus 1, that's going to be 0, and that doesn't exist. So MATLAB will crash. Similarly, if you look at the very end, if you look at the length, well, what's k plus 1 in that case? It doesn't exist. So you can apply that logic to the extremities. So when we traverse, we're going to have to start from element number 2 all the way to the end minus 1. You're ready to code at this point. So build your algorithm. We have our x and y coordinate. We need to define them in MATLAB. Plot the curve? Probably because visually you're eager to see how many peaks there are. But then you actually need to start counting. So start counting at 0. then traverse the vector from the second to last point, then apply your logic each data point. If it is true, add 1 to the counter of peak, also indicated on the graph. We'll do that very last. And then once you're done with everything, show the actual total counts. Alright, time to code. So the x and y coordinate, remember, are given. Maybe we copy pasted them from somewhere, but there's a lot of data points. The last thing I want to do is do this by hand. So it's a long vector. Instead of having it go off the screen, I decided to put little ellipses so that MATLAB automatically knows to wrap to the next line. Same thing for the y. Lots of data point, but again, I will not do this by hand. Let's see the plot, just so that visually we can immediately see the result. So, remember to ignore the beginning and the end, since there is no point before, point after, but we can clearly see 2 peaks. Visually, human, we might be wrong, but at least we should have 2 peaks. So let's see if we can do that. Let's start a counter of peaks at 0, because before we traverse, we have to have an initial point. Then our for loop. So our little index k is going to help us count from 2 to the length of y's minus 1. You don't need the parentheses, but visually this is what MATLAB sees. It's going to count from k equals 2, so the second element of my vector, all the way up to the length minus 1. So to the last element. Remember again, length is a known function. It determines how many elements are in your vector. But we don't want to go all the way to the end. We want to go all the way to the end minus 1. Now the parentheses are not needed, so I'll take them away. But MATLAB understands. I like putting my ENDs immediately. That way I can test. I can press F5. Nothing will show up, but at least it doesn't crash. It could have already crashed if I had forgotten, for example, the K. Crash. Oh, don't go further if already there is a little mistake. Keep in mind, test as you go. Alright, our lovely logic. Copy, paste. And once again, END. F5, it doesn't crash. That's a good sign. Nothing happened, but at least MATLAB went through this without crashing. If by mistake I already had a 1 here, MATLAB would have crashed. Because ys of 0 does not exist. So once again, I cannot apply this, I cannot apply this little idea, 1k is equal to 1. 1 minus 1 and 0 doesn't exist. So once again, test as you go. Add 1 to the counter of peaks. So count peaks equal. This is a running total. It's like a scorekeeper. Every time you have a game, you play, you add 1 to the score. So count peaks equal count peaks plus 1. Still runs, but we don't have a result. Now we could look in the actual workspace. Count peaks is 2, that looks good. Is it the 2 that we're thinking of? Maybe. So let's indicate it on the graph. This we haven't seen before. There is a function called text, and it will display a text on the graph. But how does it work? Remember to click on the function and press F1. It brings up the documentation. So this is how we want to use it. Usually the first option is the best and the simplest. Text x, y, string. So if we have an x coordinate and a y coordinate and we write a string, MATLAB should technically display it on the plot. Let's try to find an example. So here's the example. They created a bunch of x's, they presented y of sine of x, and on the figure they plotted it, and they wanted to text at pi 0. So remember that the first one is the x value, and the second one is 0. So at pi, which is 3.14, x equals pi, and then at y equals 0, they wanted a little text of sine x. Now they have fancy left arrow. We just want to say peak. Let's do simple first. But eventually, if you want to understand left arrow, probably there's an up arrow or down arrow. Then go back to the documentation. But always start small. Okay. So do the easy part first. Peak. The y-coordinate is something that we know because we've been looking at it non-stop. We've been trying to find the y-coordinate of the peaks. So that's y's of k. Now we need to find the x-coordinate associated to that peak. So it's definitely an x vector, but it's not all of it. You don't want to display all the x's. You want the one that's specifically attached to the peak. So k again. And let's see if it does like what we wanted. Surprise! The peak here doesn't show up. Why not? I mean, visually that's the one we were thinking about. Well, it's a flat peak. So technically, if we follow our extreme logic of strictly less than and strictly greater than, yeah, there's no peak there. But, ironically enough, there was a hidden peak. This little one. Yes, this y is definitely greater than the one before and the one after. So magically, MATLAB, by doing step by step the extreme logic, it found a peak we human didn't see. That's why programs are a little bit better than our brains. But we were very strict on that equality. So maybe add one of the equality to one of the options, left or right, it doesn't matter. Let's see if it makes a difference. Yes, it does. So now we're okay if the point before was equal, and that is considered as a peak. Now that we've solved our issues, we can do a final fprintf. Total amount, let's be nice. There was peaks in your curve. Count peaks. There you go. There was 3 peaks in your curve. Alright. So once again, the whole point of this example is to show you how to traverse a vector to analyze something when there is no function available. Finding the min and the max, there is something, so it's not really useful. But here, there is no function to find how many peaks there are and to indicate them. So we had to go step by step through every single data point. Now this wasn't actually the only way. Some of you might have thought about it this way. Instead of looking at k, k minus 1, and k plus 1, you thought about it as looking as k, k plus 1, and k plus 2. In that case, your logic is still identical, you're still comparing y-coordinate, but there's no point before. There's the point after, and the point after. So k plus 2. There's nothing wrong with that either. In that case, when you actually traverse, what should be the first k you're looking at? And what should be the last one you can apply this to? As far as the first point you can look at, k equals 1 is okay. Because if k is equal to 1, k plus 1 is equal to 2, k plus 1 is equal to 2, k plus 2 is equal to 3. All these exist, MATLAB will not crash. But you can see we have an issue at the very end on the right. We can't use the length as k, because then k plus 1 would be length plus 1 and doesn't exist. K plus 2 would be even worse, it would be 2 points after, it doesn't exist. We can't use length minus 1, because then we're still looking at 2 points after and it doesn't exist. So we have to stop at the length minus 2. So it still works, but there are different mentalities here. Once again, to wrap up, the for loop is highly used to traverse vectors. If you want to traverse the entire vector, maybe modify it a little bit, always use a for loop. The only reason you would have to change this to a while loop is if you only wanted to traverse partially. Like, keep looking at a data point until you find one that specifically we want. Then you would have to stop. But if you want to traverse the whole vector, always go for a for loop. The start point and the ending point, as you have seen, can evolve rapidly. It really depends on the logic and what you're trying to do. Which K's can you use, and that's as easy as it gets. Look at the K's, try to never hit K equals 0, and never go past the length. Inside the loop, reference the element within the vector as usual. So I had my vector's name as y's, so I have ys, and then the little k variable because that's my control variable. But that was another example.